Welcome viewers. So in our previous lesson we discussed the definition, the types. Now we want to start with set operations. So number one among the set operation is union of sets. What do you mean by union of sets? Union of sets, you combine the member of set A with member of set B. You combine them together. That is what we call union. Union means combination. You combine two sets together. So for example, let's say we have set A as this 2, 3, 4. We have another set B as 1, 5, 2, 3. And we have to combine this together. It means you combine member of set A together with member of set B without repetition. You don't repeat a member more than one. Even if that member exists in two different sets, you are still going to list that member once. So now, and the symbol for union is this. Symbol for union is this. Now, A union B means A union B. Don't write letter U, please. Now, A union B simply means you combine these two sets together, but you don't repeat. Now, here there is 1, so we have 2, 3, 2, 3, 4. Then 2, 3 is already here, so we don't need to repeat that again. Then 1 and 5. 2, 3, 4, 1, 5. So the order of arrangement doesn't mean anything. Doesn't affect your set. Either you write it this way or you arrange it in order 1, 2, 3, 4, 5. Both are the same. This is what we call equal set. So two sets are equal when they are member. They have the same member. They have entirely the same member and in the same cardinality. The same member and the cardinality of such set are the same. What I mean by cardinality? The same number of members. Their members are the same. They also have the same. They are also in the same number. Then we say the two sets are the same. Now here we have union of two sets. You combine them together without repetition. Now another one is intersection. Intersection. Number 2. Under the operation intersection of sets. Intersection means what is common to the given sets. Either you have two sets or more than 2. Here also the union, the set may be more than 2. Just combine everything together without repetition. Now for intersection, what do we need to do there? You take what is common in set A and B, what is common to A and B, or if you have 3 sets, in case of 3 sets, what is common to A, B, C, you take them together. And the symbol for intersection is this symbol for intersection. For example, we have a set, or let's use another letter now. Set X equal let's say prime number 2, 3, 5, 7, and I think these are prime numbers. Let's say we have said Y also even number. We have 2, 4, 6, 8. Let's stop here also. Now, what is common to X and Y? That is intersection. What is common to these two sets? I think what is common to both is what do we call it? Is just 2. 2 is common to both. Now, since 2 is common to both, it means the intersection of X and Y is 2. What is common to the two sets? And another thing I want to also take from this, we have just one member that is common to X and Y. So this is a unit set or singleton, as we have it in the definition of a set. Here is a equal set, equality of sets. So our result here is equal. So this is singleton. Yes, we move. We move to another, under the operations of set again. We have what we call universal set. Universal set is the set that contain all the sets under consideration. Is the set that contain all other sets under consideration. So set of all other sets under consideration. So it depends on how the question is given. So universal set varies based on the question. So but is the set that contain all other sets under consideration. So that is what we call universal set. Universal sets. Universal sets. Sometimes we use letter U to represent universal set. Sometimes we use this symbol to represent a universal set. So it's the sets that contain all other sets under consideration. For example, let's assume I may decide to use, for this example now, my universal set may just be 1 to 10, 1, 2, 3, everything to 10. Because so far, all the numbers here, I don't think any set has a member that's beyond, that the member is out of this 1 to 10. It means for all the sets on this board, the universal set can be 10. So because here is still member of this set, this is also member, their union is still member of this set. Even this, what we call it, this prime member, they are still member of this set. This even, they are still member of this set. It means, so there, here's our universal set. So universal varies. When you have a set that is bigger than this, then this cannot be universal again. Maybe the bigger one will not be the universal. Depends. That is why I said is the set that contain all other sets under consideration. Now, so that is what we call a universal set. Now, once we know universal set, another thing under set operation will now be complement of sets. I think that is where we are going to stop, so that in the next lesson we continue. So now, complement of a set. Complement, let me remove this part. Complement of a set. Complement of a set or of sets. There is number 3. Now, for example, here, before you find the complement of a set, before you look for the complement of a given set, we must know the universal set, because complement of a set are the members of universal set that are not in the set. For example, complement of set A are member of universal set that are not in set A. Complement of set X are member of universal set that are not in what? In X. For example, now, if the question says find the complement, and the symbol for complement is this, we may use prime. For example, set X, that will be complement of X will now be X. This, we use this symbol, or we use X prime like this. So this is this symbol for complement. Now our X complement here now. Now what are the members of universal set here? Because this is our universal now. 1 to 10. From 1 to 10, which of those numbers from 1 to 10 are not here? So that is complement of X. 1 is not here, so 1, 2, 3. 4 is not here, so we write 4. 5 is here. 6 is not. 7 is here. 8 is not. 9 is not. And 10 is not. It means complement of X are what? 1, 4, 6, 8, 9, 10. So they are member of universal set that are not in the given set. So complement of X are member of universal that are not in X. Complement of B are member of universal that are not in B. And that is what simply complement of a set is. So in the next class again, we consider some other operations.